It's recording. Okay, we're ready. So first thing I wanted to run by you guys, there are these assignments and this system is finally up and running. So I could post them for you guys and you could just do them for bonus assignments, I guess. I don't know, you don't have to do them. You can do them if you want to. But we've got the quiz tomorrow, so focus on the practice quiz that I posted. Okay, so there will be kind of some assignments. I'll make them due next week sometime, right? You can work on them if you want to, and then there's 3 of them, I think. So I'll just drop your lowest 3 assignments from your overall assignment grade. These are easy assignments, right? So nice to get 100%, and then you can drop some other ones later, right? And so that's what I'm thinking. So I'll post them. You can work through them if you want to. You don't have to. You can just forget all about it. But just so you're not overwhelmed when I post them. Right now they're hidden. I also posted a practice for quiz 1. It might be a little bit longer than the actual quiz. We'll see how we do, because the quiz is only for 50 minutes, right? So tomorrow in class, you write the quiz, and it's just a basic setup. Once you're done the quiz, you're free to go. Okay, but before we do the practice quiz, and like I said, I only printed a few, but I did post the PDF. So if you don't think you need a printed copy or want a printed copy, let me know. I'll check in once we get into the practice quiz. I might have to go to the dean's office and beg them to photocopy if they can, assuming they can. If not, it'll be fight to the death. No. Okay, but before we can get to the practice quiz, it's more, and oh, that's what I was saying. I would think of it more as practice for the quiz, right? Instead of a practice quiz. Right, because I'm trying to expose you to all the different things that we could think about that we've covered already. Okay, so what we were working on last day, now this is way too long for us to copy over, but what we were working on last day is using a table like this to find percentages, right? Which are really going to turn into probabilities later on. Right, but for now we're just talking about percentages, right? And so we worked through some problems, right? So what percent of these voters identify as conservatives, right? And so we had the conservatives, 490 out of 1240. And then we worked through a couple of other problems. And then we were talking about what percent of the Tampa, Florida voters who identify as conservatives are also in favor of the citizenship option. Okay, and we found that 12.04% of the conservatives, right? So of the conservatives tells me what the denominator has to be. We're in favor of the citizenship option. And then we did the same thing for the moderates. Okay, so so of the moderates, who's in favor of the citizenship option, jumped up to 30.69%. Okay? So now what I want to do is I want to continue from last day. And I want to find, I think it's part F. We're going to find what percent of liberals are in favor of the citizenship option. Okay, we need that table. I'm not going to bring it in because it's in here and it's huge. Okay. So now we're talking about the liberals, right? So we have to be, so of these liberals, how many of them are in favor of applying for citizenship? Which means that we're looking at the intersection of, okay, so they have to be in favor of applying for citizenship and they have to be voting liberal. So 183 out of 258. Which becomes, let's see, I'll use a different color here. So they have to be liberal and in favor of the citizenship option over the total liberals. Which we saw was 183 over 258. Which is roughly 0.709302326. Maybe, unless my eyes deceive me. Which is roughly 70.93%. So now, right, really what we found is that if I grab this table here, copy, paste, we found that within each of these categories, right, 59 out of 490, right, of the conservatives was 12.04%. And maybe what I can do, can I? I'll make my pen huge. Oh, too big. Oh. That won't work. 12.04%, right, of the conservatives versus 30.69% of the moderates versus 70.93% of the liberals. Now, these are not going to add to 100 across. Why? Because, right, this 70.93 is within the liberals, right? So these percentages going down should add to 100, right? And the moderates should add to 100% and the conservatives will add to 100%, but the distributions are different within each of them. Okay. So one question that we're gonna eventually answer properly, but I just want to show you that we have the skills to figure out how people feel about citizenship and how they vote. Are they dependent or independent things? Right. Looking at these percentages, right, it looks like how they feel about the citizenship option depends on how they vote, right? And so eventually we'll get to talking about dependent, independent events, but we can just look at this and say, okay, well, actually it looks like, right, knowing that someone votes liberal tells me something about the probability of them being in favor of the citizenship option, right? And so that is what being dependent or independent boils down to. Yeah, so that's why we're using percentages, right? Because it would take that into account. Right, because if we're talking proportionately.
Not a big enough gap that you can see changes if you double dip.
No, as long as all the groups are over 30 typically, we're fine. Yeah, so, but that would be the reason that we want to use percentages or proportions, because raw counts, right? It's gonna look weird, right? Awesome. Okay, so I'll phrase it as a question. I have it as a different style of question, so now I have to think on my feet here. Sure. Do political ideology, how people vote is what that means, and views on immigration appear to be dependent or independent? That's what we just answered, but. Yeah. So here, our answer is going to take those percentages into account. So what I'm gonna say is maybe something like this. Since 12.04%, 30.69%, and 70.93% are very different from each other, right? So there's a clear difference between each of the groups, right? Are very different from each other. We conclude that these two variables are likely dependent. We conclude these two variables are likely dependent. Yes.
At what point, like obviously 33%.
Yeah.
Point is it, like how much plus or minus can we go on either side before?
So there are math rules that we'll have, but they're in chapter 3. So you'll have to wait a little bit longer. Dang. But there are rules that we have that can determine, okay, these are dependent, these are independent because of this. Awesome. Okay. So that's kind of the end from last day. And then there was so little that I wanted to finish. It was just, so we talked about categorical variables, right? How do I visualize them? I use bar charts, right? Or you can use pie charts, but I don't want you to. And then we looked at a table, right? How do we summarize categorical variables? We use a table, right? Either one variable or two variables typically. And then, so the next phase would be, okay, what if I have multiple variables, right? What if I want to visualize multiple variables? So to visualize, right, because here we're going to make the distinction between summarizing a variable, right, which means doing calculations, making tables, versus visualizing variables, right, making graphs and looking at, but it's the same information, it's just how we communicate it, right? And so now to visualize two categorical variables, we can use And there are many, many, many different things that we can use, but I just want you to have kind of a basic toolkit of, okay, so if I have a numerical variable, I use a histogram. If I have a categorical variable, I use a bar chart. If I have two categorical variables, I'm going to use a stacked bar chart or a side-by-side bar chart. So we can use a stacked bar chart or a side-by-side side-by-side bar chart. What that looks like can look like, now you don't need to worry about, pardon? You should be able to just use, how did I do it? If you just use the bar plot function, it needs a table for the bar plot, but then it'll just know that it's two categories. So here, right, we don't have time to talk about all the R code here, but I mean, it's good for you guys to have. So here, the cylinders versus something. Oh, V-shaped. Cylinder V-shaped table is my acronym there. Is a table of the cylinders against the V-shaped engine. So this is car data. It's the MT Cars data set, which is a famous data set that we use for kind of teaching skills, right? So if you haven't seen the MT Cars data set, you will, and you are right now, I guess, but not properly. So then if I make a prop.table of that table, right, then I have 4, 6, or 8 cylinder cars, and it can either be not a V-shaped engine or a V-shaped engine, that kind of thing. So then what you can do is once you have this table, and even just the regular table, not the prop table, then the parmf row just puts them side by side, not on top of each other. So you can ignore that. Then you can just use the bar plot on the contingency table, which has 2 variables. So then, and then I added a legend, and that's all I did. And then to change it to a side-by-side bar plot, you can say beside equals true. So you can add that argument. So nothing crazy going on here, but this is what it would look like. How about for those interested, I'll bring the code in just so you have it. It's obviously not something that we're gonna be tested on or anything like that, but just so you can play around with it. Okay. So we can make a stacked bar chart like this, right, where it takes the categories from one of the variables, right, and stacks them kind of proportionately, right, within the other variable, right, or within the other category. I prefer the side-by-side bar chart just because it looks a little bit cleaner, right? But it depends on what your purpose is. If you're trying to compare, for example, the 4-cylinder vehicles for the V-shaped engine or the non-V-shaped engines, right, then you have a lot more 4-cylinder cars in here. So it depends on what you want to talk about, right? But for most of my purposes, I find that the side-by-side bar chart is cleaner to look at. Okay. So right here, you've got variable number 1. And here you've got variable number 2 making up the bars. If you didn't have this makeup, right, you could still make a bar chart and you can just ignore the shading, right? And that's what it would look like. Okay. So how about if I want to visualize 2 numerical variables? My go-to is to make a scatter plot, right? If I want to visualize 1 categorical variable and 1 numerical variable, da-da-da. Okay, let's see here. And then we'll have kind of a good toolkit to use. Okay, so to visualize 1 categorical variable and 1 numerical variable, we can use a side-by-side box plot is the one I would recommend. We can use a side-by-side box plot. Right, the other one was a side-by-side bar chart. Now we're going to talk about a side-by-side box plot, which is going to look like and you know what? I may as well steal this. Save ourselves some writing. Okay. Comparing numerical data across groups, right? 1 numerical variable, 1 categorical variable, creating the groups. So if we want to visualize the distribution of a numerical variable by a categorical variable, we can use a side-by-side box plot. And so here, the miles per gallon measurement in a CARS data set would be numerical, right? And then the number of cylinders, even though they're numbers 4, 6, and 8, they are just categories, right? And so we have the numerical variable by some categorical variable. And there are other ways that you could do it, right? You could look at, you could make subsets and then compare the histograms, right? However, by whatever means you want. But the side-by-side box plot is going to look like this. Which makes it relatively easy to compare a numerical variable here, right? So here we have a numerical variable, and here we have a categorical variable. Okay. So right away, I can, because these are on the same scale here, right? Then I can look at, okay, not surprising, right? Miles per gallon is high, right? If you only have 4 cylinders, because there's not, you know, a lot of engine taking up all kinds of juice, right? Whereas here for an 8-cylinder engine, we know this, right? Your gas mileage is not going to be that good. And so that's reflected in these numbers here. So it's behaving the way we think, and we can look at things like the spread of each of these, right? There's an outlier here, right? And then you can make comparisons like the medians, right? You can compare the medians, for example. There's lots of things you can talk about. I like to throw in things like the minimum value of the 4-cylinder is still higher than the maximum value of the other 2 groups, right? Just kind of look for extreme differences. But that's the point of the side-by-side box plot, is that you can look at these and you can draw these comparisons. Okay. Okay. Let's see here. Because I realized I didn't write down visualizations that we have in our toolkit. Do you want me to summarize them? Maybe? Okay. Okay. So, well, first, because I don't want to forget, it's very important. I guess How I Met Your Mother is kind of an old show now.
Well, they did do a revival.
So that's pretty good. So I can keep using them. Is that what you're saying? So Marshall's made a pie chart of his favorite bars and a bar chart of his favorite pies. I don't know. It's just kind of cute. How though? How? You can only have one favorite bar and one favorite pie. Doesn't make sense, right? Maybe it's everyone's favorite bar. It doesn't matter, whatever. That's not the point. But so our visualization toolkit, just to have a quick reference, right? If you have one numerical variable, I'm not going to write new variable every time because that's crazy. I want you to use a histogram. How about one categorical? I want you to use a bar graph. Okay. And like I said, there are so many other visualizations. It can be very overwhelming, right? And so it's nice to have kind of back to basics. Okay, this is what I'm gonna do, right? And you can start there and then you can build it out. If I have two numerical variables, I will make a scatter plot. If I have two categorical variables, I'll make a stacked or side-by-side bar chart. I'm giving you two options. Maybe I'll say a stacked bar chart, just for simplicity's sake. And then one numerical and one categorical, I'm gonna make a side-by-side box plot. Okay. So that's the end of chapter 2. Which is also the end of the quiz material, quiz 1 tomorrow. So this is, oh, lost one. When I ask you, so I did post the PDF of the practice quiz and I'll have it posted here, but I have 9 copies. And if you look around the room, more than 9, 2, 4, 6, 8, 10, 12, 14, 15. How many copies do I need to run and make? Hand up if you want a physical copy. We'll start there. How about that? Don't worry, I will go try to make some copies here. Okay, we just might. Nice, be nice. Nice. Okay, John. You guys are iPadding it. Yeah, I think. Oh, you share one? Unless she comes back. Then I'll take it. It's supposed to be under there. Is it not showing up on Moodle? Is anyone? Oh, you'll share one. Hey, look. You just make a certain amount and then that's the perfect amount. We'll see.
Oh, I have it.
Oh, it's working? Awesome. Okay. So, like I said, I posted it on Moodle. So you'll have it, but I've also got it pulled in here. Okay. So, like I said, one thing, we'll see how long this takes us. That'll give me a good gauge on kind of the length. This is long, so we'll see how we do. But let me just grab this first part. Started on a fresh page here. And I'm gonna add practice 4 quiz 1. I like to do that. I like to kind of overwhelm you with practice, because otherwise if I give you something that's, you know, that looks like the quiz, then as soon as the quiz doesn't look exactly like it, you guys are all thrown off, right? So I like to kind of give you practice for the quiz. Okay. So here, question 1. A large college class has 160 students. That's not us, but could be. All 160 students attend the lectures together, but the students are divided into 4 groups, each of 40 students, for lab sections administered by different teaching assistants, which is pretty typical at a university level. The professor wants to conduct a survey about how satisfied the students are with the course, and he believes that the lab section a student is in might affect the student's overall satisfaction with the course. First thing we need to think about is, what type of study is this? And I've given you only 2 options, right? Is it observational or experimental? Observational, because we're just sitting back and observing, how do you like this course? Right, and so it's observational. Why? Since no factor is being controlled, right? Since no factor is controlled. Off to a good start. I'm gonna bump this to the top here. Let's see here. What are the 2 variables collected, and what are the variable types? Okay, so here, there are 2 variables collected, I'm telling you that. And so let's say variable number 1 and variable number 2. Variable number 1 is maybe the satisfaction, right? Rate your satisfaction on a scale of 1 to 10 of this course, right? We do those surveys too, but we try to get everyone in the class. And so satisfaction, do we want to treat this as numerical or categorical? Okay. Why categorical? So, can't you?
We could, we take numbers from.
So this is my point. I'm happy with either or, as long as you explain why, right? So that was the argument that we developed. Well, you can't take the mean. Okay, fine. Right? If you feel that way, I'm happy with that, right? I just want you to tell me why you're saying that, right? And so for something like satisfaction, I can be convinced either way, right? It's on a scale of 1 to 10, it's all categorical, that's fine. Right? And so either or, numerical or categorical. Did you want a paper copy? Use the mean for justification. Right? So we all saw that and went, oh, we had our own opinion, so you just need to argue it. Okay. How about the second variable is going to be what lab section they're in, right? Because the professor suspects that whatever lab section of the 4 that they're in, meaning whatever lab TA they have, will impact the satisfaction. Okay, and so the other variable is the lab section. Now for this one, there's really no debate, right? You're in section 1, section 2, section 3, section 4. Do I want to talk about the average section? No, right? And so for this one, only categorical works. Okay. So categorical, since we would not be interested in the mean lab section. Awesome. It's been a while since we did this stuff, hey? Or maybe that's just me. Okay. Next thing we're going to do is we're going to identify the response and the explanatory variable. So the response variable, remember, is the variable that we're interested in, right? We only have 2 variables, satisfaction and lab section. And so here, the response variable, we're interested in the student's satisfaction, right? And we think it might be explained by what lab section they're in, right? So the response variable is going to be the satisfaction. And the explanatory variable is the lab section. Part D, can we establish a causal link between the explanatory and response variables?
Yeah.
No, anyone? No, why? Because it's not an experiment. Oh, that's all ringing a bell now, right? It's that causal, right? We can talk about an association, right? But it's the causal part that we cannot do. Okay, so no, since this is not an experiment. Now, I have this explain on here for a reason, because if I use a question like this, right, I haven't used this one, but if I use a question like this, usually I just get answers like yes or no, and that doesn't really get you any marks, right? You have to explain why it's no, why it would be yes. Okay. The number of times that I give answers to previous parts within the question is crazy, right? But maybe only I see it often. How would you best visualize the lab section variable? Telling you that lab section is a variable, right? So, oh, sorry, I couldn't hear you. Bar chart, right? Because it's a categorical variable. Good, 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 good. Bar chart, since it is a categorical variable. That's another way to ask you, right? Instead of asking explicitly, what type of variable is it? I could ask you, how would you best visualize it, right? Bar chart, because it's categorical, two birds with one stone, right? And so, right? So sometimes I ask things explicitly on the practice and then kind of condense on the quiz itself. Okay. This one is really just an exercise of no wrong answers, as long as you argue your point. So just a sampling strategy for collecting a sample of size 40 for this study. There's no wrong answer. Okay. As long as you adhere to random sampling, right? We could say, oh, I'm going to use a stratified random sample. What would that mean? I'm going to use my lab sections as my strata and randomly sample 10 from each lab section. Fine, that works. I'm going to use cluster sampling. I'm going to randomly select, but then you have to tell me what cluster sampling means, right? I'm going to randomly select one lab section and sample everyone in that lab section. And that's my sample of 40, right? Or I go into the class and I take a random sample of 40 students, regardless of what lab section they're in. That works as well, right? So lots of different options, as long as you're touching on one of the things that we talked about, right, for proper sampling, then I'm happy. Okay. So here, there's no wrong answer. No wrong answer, right? As long as the sample is randomly selected. As long as the sample is randomly selected.
What if you class randomly choosing 40 students who wants?
Yep, simple random sampling.
But then what if you miss an entire lab section?
So that can happen, and it does happen, but we don't make adjustments for that. That's just, but the simple random sampling is supposed to give you a sample that's representative of the population, right? And so we assume that, and then if we only get 2 from one lab section, then so be it, right? Yeah.
You get it or you don't?
Yeah, so, but in a class of 160 and only 4 lab sections, the probability of that happening is very, very low, right? So that's what we're relying on, right? The probability of getting a decent sample of the lab sections is pretty good.
Wouldn't it just be, could we make the argument that it's a better sample if you choose like stratified?
Yes. But That doesn't mean simple random sampling won't work, right? It just means that we can improve on it a little bit by using stratified sampling or cluster sampling, but I would choose So for me personally, I would use stratified sampling.
Seems like
Right.
the simplest and also the one that comes.
If it's important to you to have each lab section represented, which it might not be.
Well, in this case, isn't it?
Not the whole point, because we're really only interested in the satisfaction. But we suspect that the lab section is impacting that, right? So it would be nice, but it's not critical. Right.
Like, the 3 other sections have like amazing features, and the one that didn't get sampled was like a terrible problem.
Then so be it. Those are things that you would include in your report, right? Oh, I had a low number from this lab section, so I can't say for certain, right? I can't draw any conclusions about this one. And that would be an argument for using stratified random sampling. But you could use a simple random sample. And just because of how probabilities work, the probability of having roughly equal distributions within each lab section is really good. And that's why it would work. So you could use SRS, stratified, or cluster, right? As long as you explain how it would work, right? And how you would get that sample of size 40. Okay. For this next one, we're going to do a little bit more hands-on for this one. Okay. I'll let you guys, we'll read the question and then I'll give you guys some time to work on it, just because the first one was just kind of like, oh yeah, terminology, whatever. This one we have to actually do. So the 2013-14 roster of the Seattle Seahawks, winners of the 2014 NFL Super Bowl, someone's a Seahawks fan, included 10 defensive linemen and 9 offensive linemen. The weights in pounds of the defensive linemen were these, and the weights of the offensive linemen were these. Now, I want you to find a 5-number summary of the weights of the defensive linemen, which is the first row, and then find a 5-number summary of the weights of the offensive linemen, right? Just for practice. And then we're going to focus on the offensive data, I think. Yeah. So we only do the 5-number summary for, or for. Before you go too deep, you have to what? Sort your data. Okay. Even if you're still working on it. I took that time to sort my data. Hopefully I did it not too sloppy. We'll get started here. Okay. So first thing you want to do, right, is I encourage you to cross things off as you go, right? And then just count to check that you have the same number as the original, right? So I like to stack them on top of each other so I know I'm not missing any. All right. Okay. Now I'm gonna bump this down just a smidge here, give myself more line. Okay. So I want the 5-number summary. The 5-number summary is the minimum, Q1, the median, Q3, the maximum, right? That implies that we remember that, right? And so I'm gonna make my list first, the minimum, Q1, oops, Q subscript 1 usually. On a fresh page. Median, which is also Q2. If you want to write Q2, that's totally fine. Q3 and the maximum. Okay. Number one thing, well, let's get the minimum and the maximum out of the way. That's easy marks, right? 242, 323. Okay. Now time for some work. but it's pretty fun, right? We use the boop, boop, boop method. There are fancier methods, but this is all all I want you to do. So I'm gonna take my fingers and try not to go cross-eyed, and I boop, 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 and I land on 274 and 297 at the same time. So then I draw a circle around them and a line down the middle to denote that the median is actually between these two values. And then kind of confusingly, we take the average of the two, 274 plus 297. 274 plus 297, I'll just do it on the side here, divide by 2 is 285.5. And maybe I'll just use the same color for the minimum and the maximum. All right. So now, next thing we need to do is find the quartiles, right? And I've given you two data sets because there are two different ways that this can go down, right? If we have the line here, then I start from 274, right? I start on the other side of that line. So 274, 242, boop, boop, boop. I land on 254, which is Q1 is 254. And same thing here, boop, 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 303. Nice. So it's a lot of rules in the beginning, but once you get the hang of it, it's pretty fun. Or maybe that's just me. Yeah, if you use R or something like that, it'll be a little bit different because it'll use more sophisticated weighting. But these are the answers that I'm looking for on the quiz, right? Yeah.
You're gonna want us to do like, oh gosh.
The 1.5 IQR rule in part C. So not quite yet. Okay. Gonna move this up because there. 5-number summary again. We know what to do, right? And so I'll do make my list. Kind of running out of room here. Minimum. No, I don't want to do that. Just gonna put it all on a new page. Otherwise it'll look too weird, too messy. Okay. So again, the minimum Q1, median, Q3, and the maximum. So I've sorted my data, I crossed them off, I made sure I had the right number. And again, we can just, for quick marks, minimum 298, maximum 332. It always makes me so sad when people leave the minimum and the maximum blank. You can do it. Right, the other ones I get, they can be kind of rough, but okay. Median, same thing, boop, boop, boop. let's see here. How can I, boop, boop. Oh, I only did one. Boop, 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 phew. So the median is 315, right? So it's just an exercise in, I wouldn't make you do it twice, right, on the quiz. It's just practice for the quiz. Now, what's different here? Now that I've used 315 as the median, right, I start my counting at 310, right? So that's the only difference. And let's see here, 310, boop, boop. Q1 is 301 plus 305 divided by 2. Oh, thank you. I'm already on a roll here. Same thing for Q3, the third quartile starting at 318. Boop, boop. Q3 is 320 plus 321. Let's see if I can write it out. 320 and a half. Nice. Okay. Now it's time. Does the offensive data contain any outliers? Now, so here, right? This tells you which data set to be working with, right? So the offensive data is the second one we just did. Okay. So what I'm gonna do is, just so we, well, it's right there on the screen actually. How do I define, so does offensive data contain any outliers? How do we determine that? We need to use the 1.5 IQR rule, right? So justify with an explanation. So here we go. So contain any outliers, use the 1.5 IQR rule is really what it's telling you to do, right? Without actually telling you to do it explicitly, right? You have to know that. The IQR for the offensive data is Q3 minus Q1. $320.5 minus 303. Oops. Nice. Thank you. Okay. So I'm going to find the lower bound and the upper bound. How do we do that? From Q1, I need to go down 1.5 times the interquartile range, right? So Q1 minus 1.5 times the interquartile range. So 303 minus 1.5 times 17.5. 20. So 303 minus 26.25. I had it on my screen and then I wasn't hearing the same. I'm used to hearing the same numbers from you. What's going on? You're ahead of me, that's what. Okay. Good. So the lower bound, 276.75. What I'm gonna do is just calculate the upper bound as well. And then I'm going to look at the data. So for now, I'm just gonna grab my tools, so to speak here. The upper bound is Q3 plus 1.5 times the interquartile range. Why? Right, because I need to go from Q3 and I need to go up. One thing that I will say is that I'm mean and I'm not going to give you these formulas, right? Because these are conceptual things that we need to know, right? I'm going down from Q1 and I need to go up from Q3, right? So you'll need to memorize these, right? I don't think there's much memorization to do, but just remember the minus versus the plus. So then, oh, you guys are way ahead of me. 320.5 plus. I'm gonna just go straight to 26.25 because I showed the work earlier. You're allowed to do that. I keep hearing it, but I have to see it for myself. Also, I want to have it on my screen. 346.75. So now what I'm going to do, right, is because I have it, I'm going to just copy. Or maybe I'll keep that, right? But we don't need notes. Yeah, 303 and 320.5, just so we have it. Okay, so now, right, these are all sorted. These are the points in my data set. So now what I'm gonna do is I'm gonna draw 276.75 on this number line. It doesn't become a data point, 276.75. So I draw it kind of up or down, right? This tells me that there are no outliers on the lower end because all the data points are within that bound. Nice. How about on the upper end? Oh, womp womp. Right. So my explanation then would be there are no outliers in this data set since all values are within the upper and lower bound. There are no outliers in this data set, but we had to do all that work to figure that out. Since all the data is between the lower and upper bound. Nice. Which group of players tends to be heavier? So what I'm going to do is I'm going to compare the 5 number summaries. That's all I have, right? I could make more calculations if I want to, but I don't want to. I don't feel like it. So here, this was the defensive data. So I'll put a label on it. Versus the offensive, or I guess offensive if you want to call it that. Just feels weird. Looking at these values, right? I'm going to do the same thing that I did with those box plots. Remember, those side-by-side box plots are really just 5 number summaries visually, right? And so I'm going to do the same thing. And what I'm going to see, or what catches my eye at least first, is 298 is the minimum the offensive data. But 298, if I try to line it up, right, that's almost on par with the third quartile of the defensive, right? And so the lightest player in the offensive is among the heavier of the defensive, right? And so that tells me, and you can confirm it, right? Overall, the medians, you can compare the medians, right? All these values are just higher, right? And so since these values for the offensive data are just higher than the defensive data, right? They tend to be heavier. Okay. All the offensive values are larger than the defensive values. So the offensive players tend to be heavier. Making sure I'm not mixing those up because it doesn't mean anything to me. I'm not a sports person. So the offensive players tend to be heavier. My main concern is just finishing this question because it's kind of the most involved question. And then what I'll do if we run out of time is I'll post the answers to question 3 in the notes, right? So I post the notes, it'll be in there. So I'll fill them in before I post them. But this is where the meat and potatoes are. Find the mean weight of the offense. Is that where we are? Yeah. X bar offensive. I know you have it. 313.3. Is it repeating?
Yeah.
Nice. Okay. Just because I don't want to do it. Right. What do? You add them all up, divide by n. Right. I don't need to give you a formula for that. I guess I will, but you don't need it. We needed that to answer this next question, though. That's why we couldn't cut it. Are the mean and median similar for the weights of the offensive linemen? So here I'm always talking about the offensive linemen, right? And so the mean versus the median for the offensive data was 315. Now here, again, you can argue it either way, right? I'm happy with whatever argument you throw my way. What I'm gonna say is that these are relatively similar, right? Looking at my minimum and my maximum values, right? 313.3 and 315 are relatively similar, which tells me that this is most likely they follow a normal distribution, right? Because the mean is roughly the same as the median. Right? And so since the mean and median are roughly the same, right? And so that's, again, just your judgment, are roughly the same. I suspect the distribution is approximately normal. Yeah, if you tell me, so here I would have a hard time accepting that 313.3 and 315 are different, right? So then I might write you a note saying, are they though? Right, we have to be kind of flexible. And the reason I say they're similar is because I've got this kind of range, right? 298 to 332, so a difference of 2 in there is not really going to make a huge difference, right? And so, but if you told me that they are different, then what would the distribution be? Then it would be, if the median is 315, right? Versus the mean being less than the median, would look like this, right? The median would be here and the mean would be in the lower tail skewed to the left. And I'm out of time. Can't remember what the last one. Oh, we can do this one. So here, this is why I have using your answer from the previous part, right? So I said, so my argument was that it was normal, which means I'm going to use the mean and the standard deviation, right? And if you told me that, okay, it's going to be skewed to the left, then you should be using the median and the interquartile range. And that's, I'll write that down before I post them, but I know I'm all out of time. So if you have any questions, let me know. Otherwise, I'll see you here tomorrow. Quiz 1. Yes. No problem. Oh, where? Yes.
I just said here, I don't see the September stuff.
The which? Oh, because I hit it.
Yeah, okay,
Because it was too, I don't know why it was showing up there.
okay.
It wasn't supposed to be there.
Yeah, yes.
Okay, yeah.
So about the assignment, there was one assignment. I just see there. I don't see the
Yeah, because I didn't make them, I wanted to mention it to you guys that I will post them, but don't be freaked out when you see them. Yeah. No worries. See ya.